So first of all, I would like to thank ACDLabs to give me the opportunity to show you the project we are developing together regarding a system combining LCMS and NMR to automate chemical structure verification. So I will start with an introduction to explain you the context of the project and the objectives. I will show you the global process of the tool, and then we will go through NMR to show you the process and the evaluation of the process. Then we will switch to LCMS process, and I will show you what was the evaluation of the reliability of the system. And then I will go through the combined tool presentation that we are using now in a test environment. And I will finish with a short conclusion. So I work for Sanofi within the structural analysis team in support to synthetic chemistry. Our missions are structural analysis, conformational analysis, and chemical structure verification for the chemistry follow-up or for the chemists in Vitry and Chilly-Mazarin site for Sanofi. We are using LCMS and NMR. So for small molecule, we are doing about 10,000 full analysis per year. We are working also for intellectual property. We are preparing the analytical part for the patents, and it is about 1,200 NMR and LCMS full descriptions per year. And now, since several years, we are doing more and more LCMS structural analysis for antibody drug conjugate chemistry follow-up. We are doing DAR evaluation and free drug quantitation. This represents about 1,800 analyses per year. So this is the context. At the beginning of the subject, it's maybe 10 years ago, the initial target was to have a tool for NMR analysts to suppress repetitive tasks to be more focused on those which need NMR expertise, like elucidation of unknowns or complex structures. And we wanted also to speed up NMR descriptions for patents. So we imagine a system which can treat and verify the spectra, NMR spectra, regarding structures of an analytical batch and give us automatically the results. So this global process is in place for NMR data now. When a chemist asks for an electronic analytical request, here, the chemical structure is extracted from our LIMS. When the experimental data is available, the automated tools make a compilation, process, evaluate the structure, and give a spectrum descriptions, and then send the results on a mailbox that the analyst can get into to check the results. For the system, we need to have 3 different modules from ACDLabs: Spectrus Processor, Spectrus Predictor, and Spectrus Database. We had a new target at the second time to have a tool for chemists at this time, because we had several R&D reorganization, and the ratio chemists and analysts is going to drop, so we were less and less analysts to do the job. So we wanted to have a tool for chemists to propose an evaluation of the compatibility of their structure with NMR spectra from open access experiments. So we put in place the right part of the chems here, which is the same as the left part, but at this time the results are the data are generated in open access mode. And also at this time, every chemist who asked for an analysis received the result directly in their own mailbox. And now we are working on the global process combining NMR and LCMS. So if we get into the process of compatibility evaluation from NMR data, we have two different processes. The first one, when the chemist asks for an analysis, the system is able to see if there is the same structure is already in our limbs. If it's the case, the system compares the experimental data with the reference spectrum already in the limbs, and the system evaluates what we call a high quality index, HQI. If the HQI is more than 90%, the structure is declared compatible with the expected structure. And then a PDF report is instantly prepared and sent to the chemist. So this is the kind of mail received by the chemist. In the title of the mail, it's written one similar structure has been found in the limbs. You have a direct access to the PDF report with the conclusion here. It seems that an identical is described in the limbs, and then the old batch, which has been compared to the new data, the HQE, the spectrum, and the description of the spectrum. If there is no similar structure in our limbs, the system compares the experimental spectrum with a predicted spectrum extracted or calculated from the knowledge database used for prediction. A match factor is calculated. If the match factor is more than 0.8, the structure is declared compatible with the data. A PDF report is generated and sent directly to the chemist. So this is an example of the mail received by the chemist. Here in the title, the match factor is good. Here is the report for the batch XXX with the match factor, the match factor, and the structure is compliant with the expected structure. If the match factor is not good enough, you have this kind of report, and the conclusion is compliance to be verified, so the chemist can ask the analyst to verify the data. You also have a direct link to the batch point spectrus file, and you can have a look on the spectrum and on the way of the spectrum, on the way where the spectrum is assigned. What is also very interesting is that with the spectrum you have an automated description. So in one click you have the multiplet journal. You can have it under different templates. You can manage your own template and define and customize it. And we have also different kind of template if you want to do a scientific publication on a specific scientific journal. So if we have a look, we can have a look on how the prediction and the interpretation is done. So here you have an example of a simple spectrum of a commercial compound. You can see that the match factor is not good enough. And if you see the spectrum, you have green parts and a red part. Of the peak in green, it's considered as well interpreted. And you can ask the system for an explanation on the interpretation of the green, of the red one, for example. So the red one is the proton 5. So proton 5 is not, there is a problem on the interpretation. So if we click on the proton 5, you can ask the system and you can have a look on which structure is used from the prediction database to interpret this signal. For example, here, this is the structure extracted from the database, and you can see that the chemical environment is not very good regarding the chemical environment of the structure that we want to have a result. So the result is not very, we cannot trust the result. If you use a user prediction database where we have a more reliable structure in it, you can see here that the match factor is very good because the prediction database is better enriched than the commercial one. So the results are reliable only if the prediction database are well enriched. Another example, just to show you the importance of the prediction database. On the bottom of this slide, you have an experimental spectrum, quite complex one. And then you have a predicted spectrum only from the commercial database. And you can see that the match factor calculate when we compare the two spectra are quite bad. And as we enrich the database with more and more interesting structure regarding the structure that we want to analyze, the match factor can drop and can be very good when if the prediction database is well enriched. So regarding the reliability of the results, we made a small evaluation on 150 compounds analyzed on 2 open access spectrometers, 400 megahertz ones, with 6 chemists in open access mode in 2 different sites. So the results are reliable for the scale-up teams when there is already a batch with the same structure in the limbs. It's very reliable in this case. The system, as I said earlier, is highly dependent on the quality of the prediction databases. So we regularly update users database. Users database is our own database with our own structures. We have quite false negative results when we have overlapping signals, when the sample concentration is not good enough, or the quality of solvents. For the concentration, we have a warning on the report when the signal to noise is not good. We have also false negative results if the sample is not pure, but it's not really an issue because if the sample is not pure, the chemist has to purify it again. And we have also false negative results regarding integration parameters. And at this time, we are working with ACDLabs to improve these items. And also, what is sure is that automation will be difficult for mixtures when you have isomers and rotamers, for examples, because spectrum are complex. Automation is also difficult for salted structures because we have some shifts in some peaks, so it's difficult to automate it. So for the LCMS, we start to think of an automated system 2 years ago. And we built a simple system with a daily database. When chromatograms, MS data, and structure is stored, system is interpret chromatogram and structures, and then gives results on UV purity and MS compatibility automatically. So the system, when he knows the structure, and when the LCMS is done, the system extracts the theoretical M plus H from the GIC positive. It's called the XIC. If there is no peak, the system declared fault to detect peak. If the system sees a peak, it extracts an MS spectrum at the XIC retention time and calculate a match factor on this mass spectrum. If the match factor is less than 0.995, the structure is declared not compatible with mass spectrum. If the match factor is more than 0.995, the structure is compatible, and then the system integrates the UV peak at the 6 retention time. And we have different kind of conclusion from MS compatible more than 95%, if the sample is more than 95%, to mixture with expected structure if the compound is less than 80% in the mixture. If there is no UV peak, there is no conclusion. We have asked ACDLabs to develop 2 different macros regarding salicylic compounds because the theoretical M plus H was not well calculated, so now it's good. The mass is well calculated. It's the mass of the base. And also we had a problem when the compound were not ionized positively. So if there is no Xic from the TAC positive, the system automatically extracts M minus H from the TAC negative, and then redo all the process as I told you earlier. So let's have a look to this daily database. Here you have an example of some data. You can customize the visualization as you want. Here is the UV chromatogram. The structure, you can have a look very easily on the conclusion of the compatibility and the conclusion on the purity. You have also colored flagged, as I showed you earlier. So every flag which are in red, we have a problem of purity. And in one click, here you have the possibility to open the PDF report which explain the results. So it was the first tool developed for LCMS. It was not completely automated, it was semi-automated too. So we have evaluated the reliability of the results for LCMS on more than 100 compounds with two different UPLC SQD systems in two different sites. So this data was not open access, was not done on open access mode. It was the analysts who have done the experiments. So for these results, 60% of the results were consistent with what I called manual analysis. We had a very, very few false positive results. I remember we had only two false positive results, and it was isomers of position during alkylation reaction. So it was not possible to say what kind of isomer we had. At this time, we had also 40% of false negative results. It was an issue with retention and integration. So for the new system, we had a pick-picking macro, a specific pick-picking macro for each instrument and method. And we also had issue regarding sample preparation. For example, when the sample was not concentrated enough. And we are thinking of if we can put a warning on the signal to noise of the UV peak, but it seems to be quite difficult to put in place. So regarding isomers, it's not possible to have positive results, but if we combine NMR, we hope that there will be no more issue. If we are in presence of non-ionizable compounds, it will be an issue. And also we need to test this system live with sample prepared by the chemists. So now let's have a look on the new development that we are testing now since several months. So the combined NMR LCMS tools. Here is an example of automated emails received by the chemists. On the left, an email regarding NMR results. For example, here, good match factor with a link towards the PDF report. The match factor. And on the right, the same for LCMS results, the compatibility, a link towards the PDF report, the conclusion of the sample and the purity. And you also have a direct link access to the analytical data and results which are stored in this new database. So if you click on this link, you open directly the database on your sample. In the first page, you have a sum up of the results. On the left, the analytical method with the purity, the compatibility, and on the right, the NMR match factor and the spectrum description. If you click on the chromatogram, you can open the Spectrus processor to see what have been done on the chromatogram and on the spectrum. If the integration of specs is good and if the interpretation are okay for you. If there is an issue, you can change the integration, the interpretation, and then you can put the new results on the database. You can update the database. For the NMR data, it's the same. If you click on the NMR spectrum, you go into Spectrus processor part, and you can see the spectrum, and you can carefully watch the calculation protocol to see if there is something to do with the evaluation, if we need to enrich the database to have better results, and if you agree with the interpretation. And you can also correct the description of the spectrum. And here also you can update the database. So to sum up, we are using now in test mode the automated structure validation verification tools combining LCMS and NMR. Now we have 12 trained chemists on 2 different sites. We manage data from 3 UHPLC MS systems with 2 different LC methods each. We manage data from 3 different NMR spectrometers, 400 MHz. For each user, they received emails with direct link to the analytical database, and this database proposes an automated proposition of UV purity and MS compliance with PDF report, an automated proposition of NMR interpretation, and an automated proposition of NMR description. So I repeat again, the interpretation is reliable only if the management of the knowledge user database is well done. And also the automated proposition of NMR descriptions must be validated by the analyst to be used later for the patent description. Thank you for your attention. I will be pleased to answer to your questions.